we're still gonna have one more minute before we go to Guillaume. Just for the ones who are here and don't know what this event is a webinar by Architects for Future. Architects for Future, for those who don't know, it's a group of architects originally from Germany who started in 2019 to meet as Architects for Future. Everybody is concerned about the climate crisis, the biodiversity crisis, and wants to do something about it. It's not just architects, it's also engineers, it's Fachplaner, it's urban planners, it's academics. Our problems are interdisciplinary, and so are we. There's regional groups, many of them, I think over 30 actually, in Germany, but also some in Austria and in Switzerland, and as I think also in Holland now. So we're becoming more and more international. All work is on a voluntary basis. We have working groups working on the diverse subjects we address. Please go to architectsforfuture.de for the German page or .ch for the Swiss one. If you want to contribute, if you want to work with us, if you want to be part of it, just join to the webpage, join to our Swiss. For example, for the people from Zurich, we have a Telegram chat. Join the Telegram chat. You find it on our webpage, or just drop us an email. With this, I'm closing the introduction and let's say the context, and I'm going over to our guest tonight. I think that's why you are all here. Guillaume Habert. He is a PhD originally in structural geology. Since 2012, he's an associate professor for sustainable construction at the ETH Zurich. And we figured actually in the Zurich group, he's so well known that a lot of Zurich people said, oh no, wait, Guillaume, I saw him 2 weeks ago. I can't come tonight. I just heard him. He's very visible here in our local community. He leads a group of scientists, engineers, and architects that aim to ground sustainability in the disciplines of the built environment. And well, Guillaume, I think without further ado, I would like to give the word over to you. And I'm really exceptionally excited and curious to find out what you have to say about renovating buildings, how we're going to do this. Guillaume, hello.
Yes. Well, thank you very much, Hans, for the very nice introduction, and thank you all for being here tonight. And yes, and indeed, it's also a great pleasure for me that to be here. And we have been discussing with Hans for I think quite a long time. So I'm really happy that we have the occasion that I have the occasion to present a little bit what we do. You should more or less see my presentation, and like, whoops, if I like this, yes, I would it like this. Okay, so renovating building, yes, but how? I start directly from the because I'm sure, I mean, if you're listening to Architecture for Future podcast or webinar, is that you know that we are in a catastrophe, or at least emergency in terms of urban climate. So I start with that relatively briefly. It is well known since quite a long time that we have a climate problem. This is internal report from the president, the scientific head of science in the president office of the United States in 1977, Frank Press, who says, you know, release of fossil fuel CO2, there's a possibility of a catastrophic climate change. It's sure, I did my calculation, it's probably 2-4 degrees by the end of the century. We need to act. He did that in 1977, and we didn't do anything since then. So I was born in 1977. So basically my entire life, we didn't do anything really to curb the CO2 evolutions. And you know that the target, I mean, why we have such an emergency in terms of action is that the current CO2 concentration is 420. If we reach 425, which we will do in like 2-3 years, we have passed the 1.5 degree. And if we pass 475, it's 2 degrees. So it happened in like 10 years. Although I put it a little bit like this, although you might think that climate science, and it's not a critic of them, but you might think that climate science is a very complex science. I'm sure it is a complex science. It is also extremely simple. CO2, once it is emitted, whatever the CO2 is, will stay at the atmosphere during at least 10,000 years. So kind of infinity. And the global warming is actually linear. You have this graph, global warming, so the increase of temperature between 1850 to this one is, cumulative increase of temperature. It's kind of linear. So, each time you add CO2 in the atmosphere, it stays forever and it increases the temperature. So the only question is how much CO2 you still emit in the atmosphere, and then we know how much CO2, how much climate, what will be the increase of temperature. So with that, very simple logic, it means then we have we come relatively fast to the fact that we need to cut drastically the CO2 emissions in the atmosphere, and therefore we have a carbon budget. So that's the work that Yasmin Priore did in collaboration with Thomas Schüsselm in recent work, but she looked, and you have many others that have done kind of similar logic. You say how much CO2 we have available, 400 gigatons CO2. How do we split per people? We can discuss, and I'm happy to discuss in the chat afterwards what would be fair, not fair in terms of carbon budget. But then we arrive to kind of a carbon budget for Switzerland. You add the storage net negative emissions that we are probably are doing or will do, and you add the importation, and you arrive to, you split depending on your buildings, industry, transport, etc. You arrive to a kind of remaining amount of CO2 that we have for the built environment. That's to operate the built environment. That's to build the built environment. New building, renovating building, and heating the residential building and the others. So to make it simple, you have 75% of the carbon budget for existing buildings, like if you take all this plus the renovation. And then we have 25% of the carbon budget that can be used for the new construction. And with this, we need to adapt. We need to adapt the existing building stock. So that's all the buildings that we have built in Switzerland, and we need to build a few extra buildings, this one afterwards, and then that's it. So in my talk now, I will focus more on this, like this renovation of 75% of the existing buildings, so the ones that are not energy really efficient, the built before 2000. And what do we do with them? We need to renovate them to reduce their energy consumption. And the question we have is like, what is the best renovation scenario? Thinking best, how do you define best? What is best for the economy? What is best for the environment? What is best for the users inside the building or for the owners of the building? What is best if I think of one building, or what is best if I think of the full building stock? And of course, depending on how do you consider the situation, you have maybe a bit different answers. And of course, yes, and then we see, I would say at least the environment is probably the non-negotiable target. And then if it's good for the users, it's probably more towards a social justice question. If it's good for the owner, it's more economic strategy question. Let's discuss. So you have different possibility to renovate. One, you could say I demolish and I rebuild everything. Or you could say I renovate, and if I renovate, do I renovate the envelope? Do I renovate the heating systems? And if I look at the heating system, do I just change do I keep the same one, or do I change one? And if I change, do I change for wood, for heat pump, for district heating, for etc.? And do I scale these solutions? So that's and I will try to make this interactive. I will try. I'm not sure it will work. Let's see. So that's again Yasmin Friore. I mean, again, another work that she did, looking at if you look, it's a parametric model. So you would say, okay, in 2050. If we renovate and that the consumption of the operations, so kilogram CO2 per square meter per year, like your energy consumption emission during your operation for the new building, for the renovated building, and then how much energy emissions you spend to renovate your building, to build your new building, and how many new buildings you renovate, 1%. All this is kind of business as usual logic. And if we link in Switzerland, then we arrive to 500 megatons CO2, which is way above our 2-degree target. 2 degree would be 400. Yes, and then the Swiss target and the 1.5. So what do we do? My first question, and that's where I had tried to have any interaction. I'm not sure. You can, maybe I'm a bit too, maybe I'm doing this a bit too much. I try. If I might do it more on the maybe on the chat. If you just raise your put a thumb up if you say we should increase the renovation. That's why it's my question. If you the renovation, the current maybe I'm not really clear. The current renovation is like 1%. You could increase to 1 to 10%. Do you think it is a good idea to renovate more the buildings? That's my question. Maybe I mixed a bit. I see a yes. You say yes or you say no? If you say yes, those who say yes, you put your thumb up. No one wants yes. Renovate. There's an interest. You're happy to renovate. I show you the results. If you renovate more. Yeah, sorry, I had a Slido, but I'm not sure it was so so well. Let's do it like this. So if I renovate more, that's what will happen. So in my I renovate more, I move to 10%, and you see, I don't know if you see actually you see nothing. You see, if it was 506 before renovation, and then it is 508 after 10% renovation. Why? Because the typically before you had all the emissions linked to the operation and not in the embodied emission, and now everything in the embodied and nothing in the emission. Basically, you have changed nothing. You have just changed the way the people who's building. So going the other way around, thinking, what are the solutions who allows us to stay below the 1.5? And then we look at all the, it's a nice diagram, but it's like all the, let's say, possibility, the web of solutions that are possible. And then suddenly you see this, you see that the rate of renovation, you can still work with 3% renovation. The same for the operation, and the is not so much critical. The thing that is absolutely not possible is to have embodied, so to emit CO2 for the renovation that is too high. The same for the new, that we absolutely need to be like negative in our solutions. Minus 120 kilograms CO2 per square meter per year would be the type of renovation that is the only one that will allow us to stay below the 1.5. If we go towards the Swiss solution, so not the 1.5, something in between the two, it's a bit less radical, you see, but still, you see that kind of all the solutions will allow, all the possibility will allow to reach this, except if we are too intense in the emissions, embodied emission for renovation and for new construction. We need to be careful about this renovation. And that was my point of renovating. How we need to we need to take care about the materials that we are using for renovation. And to be kind of radical in the sense, how do you renovate with minus? How do I get a minus CO2 in my renovation? Then, well, I need to store carbon in my renovation. And you have here, this my 3 examples. You have really nice example of renovation that are storing carbon in the built environments. I mean, storing carbon in renovation. This is a nice example. I don't know if you know it, from Graubünden, from Atelier Werner Schmidt. It's a renovation in a straw bale house, old houses where he put like a 60 whatever centimeter of new straw bale on the old facade. You have a wonderful building that is completely integrated in this. I mean, in the architecture aesthetic of the place, and but it's in straw bale, so it means it has stored carbon when you renovate it. You have other example. This is in Paris. I'm from Paris, but also that's why I think maybe I'm kind of biased. But this is a nice example of a hempcrete renovation here on the facade. And again, you don't see. I mean, it's completely well integrated. It doesn't look like a hemp facade. It's historic buildings in Paris. Here, it's a straw bale renovation that has been done recently in Paris again, with 50 centimeter straw bale on these walls. They have put here. You see they have put straw bales on the facade. The really cool, funny thing is that it's like it's overhang. It's suspended straw bale. The feeling you have like rope that are suspending the straw on the walls in the bottom, and on the top it's with a classic wooden frame and your straw bale stuck in between. So you have solutions to actually put massively straw bale, or at least bio-based materials that are allowed to store carbon in your renovation. And with that, you can reach probably something that is like in this kind of minus 100 kilograms CO2 per square meter per year. The other thing, and maybe I will keep for the discussion afterwards. The other thing is, okay, I put my straw bale. Is it cool? But is it? That was my question here. Are you sure it is the most economic way of doing it, to put straw bale in the facade? And should we not think about window before, or heating systems? Like, what straw bale? I like straw bale, but what else? Is it all we should do to save the climate? And so that's another work that Alina Galimshina, a PhD that now postdoc at ETH, who she has worked on this renovation solution, which I will now show you. She looked at all the possibility of renovation, including uncertainty, thinking in the future, maybe the climate is not the same, maybe the energy mix, the costs, etc. are not the same. What is the best solutions? And she reached, and I will show you briefly 3 results that she did. One is, if I use just conventional material on a very conventional building in Switzerland, what do I do? She looked from the CO2 perspective and from the cost perspective. What is the best? If you use a heat pump, a wood boiler, or if you keep the existing building technical systems. She arrived, and I just want to make it brief, she arrived to solutions which I think are interesting, in the sense that if you look, you're always keeping the windows, and the amount of insulation that you use is actually very small. It's 10 centimeter compared to Switzerland, where classic renovation would be like 25 centimeter. So it means that from a cost perspective and from a CO2 perspective, the best renovation is something, if you use bio-based, if you use conventional material, the best renovation is something where you don't renovate too much. Basically, you keep the window, you don't insulate too much, but you change the heating systems. You go for wood pellet or for heat pump. And of course, this has a problem, because it means if you don't insulate too much, then someone needs to pay the energy bill. So basically, compared to what is the best, it is the best from a cost perspective, but it means the user is paying the energy and the owner don't invest too much. So from a social justice perspective, we could think, is it really the optimal way of doing it? So that's why we say, okay, well, and if I use bio-based material, what happens? If I use bio-based material, it's completely different. Suddenly, this is the amount of insulation we can use. And if you see red is with the fossil and yellow is the straw, the solutions that appear are the solution where you use as much as possible. It's here the volume. So you use a lot of bio-based material because of course, the more you use, the better for the environment it is. You increase a little bit the cost, but it is still better from all other solutions. So you have solutions where suddenly the best solution is something where I use a lot of bio-based materials, which then reduce the energy and reduce the cost. And we did that for many different buildings in Switzerland to look at the result. And I just show you your result here. From the environmental perspective, if I use conventional material, this is what the best I can achieve, like 6 kilograms CO2 per square meter per year. And this is what we do with conventional. You know, you see, it's always better. Whatever the initial energy consumption, this is the initial energy of the building, so before renovation. And here we cover all the type of buildings from Switzerland from 1910 to 1988. So whatever the initial energy, it is still much better to do bio-based materials. And what is interesting is for the cost is also the same. Whatever I do, you know, conventional material, if you look at the uncertainty, you are more or less always cheaper from the overall life cycle, the cost over the life cycle. You're always better if you use bio-based materials. So it is the cheapest option. It is the most environmentally friendly option if I use massive amount of bio-based material, and of course that I change my heating systems. And that's maybe my last graph. If I cut not by over the total CO2, the total cost over the life cycle, but I look at these embodied and operation. And here you see suddenly the embodied is actually it's negative. So it means if I use bio-based, I am negative. So I'm in this minus CO2 options. If I use conventional, I am positive. And the total CO2 during the operation is smaller. So I'm winning on both sides. And of course, from a cost perspective, the overall cost is smaller than conventional, but the investment is a bit different. It's like investment, yes, you need to invest more because you put more bio-based material, but you will save in your operation. And overall, you will always save. And with that, maybe I open the question. I just have the summary is like, if you start from the first things on renovating, yes, you should, of course, but how? First, you need to change the heating systems. There's no way you can save with your oil boiler or your natural gas boiler. It's like we need to change the heating systems. That's the first things we do. Then we need to renovate. If we renovate the envelope with conventional material, we have to be extremely careful not to change the window and to use a very small amount of insulation material. Otherwise, the embodied emission of this conventional material like polystyrene and things will increase even more the CO2 emissions. So it's kind of not a great option because we can't put too much insulation. On the contrary, if I put bio-based, then I can put as much insulation as I want because I will store carbon. So I put as much insulation as I want. I still don't necessarily change the window because the embodied emission of the window is too high and doesn't pay back. And I change the heating systems, of course, for all. And with that, I have a solution where I have reduced the energy demand because I have put a lot of insulation. I have reduced the embodied emission because I have stored a lot of carbon in my bio-based insulation. And then I have a perfect, renovation. The only thing that we need, where I say changing window, is like the initial energy performance in Switzerland. Usually the building, they are actually relatively good, well insulated. So if the initial energy demand in kind of kilowatt per square meter and per year is higher than 150 kilowatt per square meter per year, then maybe you should change the window because it will pay back your renovation. And with that, I'm looking forward for the questions. Yes.
Guillaume, thank you so much. This was awesome. I loved it.
Thank you.
Great presentation.
I was fast.
It was fast, huh? I tried to take notes. I will have some understanding questions, but
exactly.
Yeah. Hey, everybody. I think from everybody, thank you so much for your presentation. The Q&A is opened, so please, if you have questions, put it in the chat or just switch on your video camera and just we go through them one by one. I saw, Guillaume, maybe we can break
Yes.
the ice. Very early on, there is a question in the chat from Christina Potts. Christina, do you want to pose it yourself in the video or should I read it?
Hello there. I can pose it myself. Unfortunately, my camera doesn't turn on. I'm sorry. Well, first, it cleared a little bit afterwards when you continued talking, but I wanted to know in your scenarios that you were comparing in the very beginning, like which quality of the renovation were you comparing? Especially because that's then my next question, and I would add immediately. I'm usually referring to a study that was done in 2019 in Germany by the Fraunhofer and by the Steinbeis Institute on life cycle, like the same, addressing the same things that you were addressing now in your studies. And they came to a much different conclusion. So I was interested on which standards you were working on and which time frame you were using for the life cycle. So if these things are comparable and if it's just difference between Germany
Yes.
and Switzerland, or a little bit
So
more on the background information that you put inside.
What do you mean in terms of that they came with different conclusion? This is this type of questions that.
Yeah, well, they were like, what is the best standard that we should go for in renovation? And it was a very high standard and like thick insulation. And you were saying that you were talking about 10 centimeters now, which I found very surprisingly.
Yes, I mean, if I look, I mean, this maybe it's a bit of a fancy way of looking at the solution. I mean, somehow it's a parametric. You can act on different parameters somehow, and I think what we show with this, but it's really simply calculation. I think, and you will arrive to kind of relatively. I think. I mean, I don't know in Germany, but I think probably a bit the same logic. What you see here, if you see the blue, like let's say what is colored in blue means you have possible scenario where you will achieve the 1.5 if I have an operation consumption of 10 kilograms CO2 per square meter per year, for instance, here. If you see my screen. So what I mean here, what I see is that of course the quality of your renovation counts. Is like if you're completely energy inefficient, it will not work. But what counts most is the carbon emissions that you put for achieving this energy performance. And what we show clearly, so it goes to your 10 centimeter. What we show clearly is that if you don't care about the embodied emission or related with your renovation, so the amount of emissions related with the material that you put for renovating, you will actually emit CO2 to reduce energy. Maybe I'm a bit confusing, but the problem with renovation, tackle in another way. The problem with renovation is that people are thinking energy and not carbon, to make it simple. We have energy efficiency of buildings. And what counts for the climate is not how much energy you spend, is how much carbon you spend. And so if rather than having an energy view, you have a carbon view, which is here. And if you think how much carbon I emit during my operation and how much carbon I emit to renovate, then suddenly you realize that the 20 centimeter, the 10 centimeter extra polystyrene that you put between 10 centimeter and 20 centimeter polystyrene, it will release carbon, it will reduce energy consumption, but the energy that you use, because you have a technical an energy carrier that is relatively renewable because you have changed to heat pump or to district heating or whatever, you're saving energy that is actually low carbon. So you emit carbon to save energy that is decarbonized, and so it doesn't save your carbon strategy. So that and this is really the question and the main point where I am pretty much convinced that you will have at different level, maybe it's not 10, maybe it's 12 centimeter a bit, but the same logic that suddenly you realize that the scenario here, you see the scenario that do not work is the scenario where the embodied emission of the renovation is too high, or and of course the embodied emission of the new construction is too high. But that your consumption, your energy efficiency, if you think it in terms of carbon, you move from 0 to 10. So you have all the range of possibility. I don't know if that answered a bit your question, but kind of.
It's a little bit more clear now, yeah.
Thank you.
Thank you. Still, to get down to that number, it's kind of hard work.
And also to because effectively maybe I was a bit fast because I dumped all the numbers in order to have the discussion. But typically, what the other way of looking at it, once we move from to an energy perspective to a carbon perspective, and we say, okay, let's think carbon for the construction and carbon for the operation. Then we realize that I should not put too much bio-based, I should not put too much insulation if my insulation is emitting CO2. But then suddenly all the things is completely changing if I can put bio-based insulation which have a negative CO2 emissions. So then it's like, oh no, I will use as much as possible insulation. And then you go in the same logic as the passive house, the more insulation you have, the less energy you will have. So of course, it's better to reduce your energy consumption, but you should reduce your energy consumption through insulation material that do not increase the problem, but that improve the problem. So through insulation material that actually store carbon and not release carbon. Yes.
Yes,
There was a big.
If I just may jump in with one comment, and I hope, Guillaume, I'm not ruling over you, but these events are really also a lot about connecting. So if you Google Guillaume, you will find his contact details. I hope it's okay to say that, Guillaume.
Yes, of course. Yeah.
I would really invite all of you to continue talking about this amongst yourselves. So also maybe to follow up with Guillaume if you really have some very detailed questions. I hope, Guillaume, that's okay with you.
No, for sure. I see one question. I'm not sure if I mean I see one from Jacob Schneider. If I take by order.
Yeah, by order. If we go by order, just real quick, there was a comment, but I think it's only a comment first from Michael. Michael, do you want to make the comment yourself? Just by I have my little list here.
Yes. Okay.
Michael, otherwise
yes.
I'll just.
Okay. Hello. Yeah, I said that if we go for massive struggle retrofits, then we obviously have very high performance walls, and when we keep the 2-pane windows, we will have a lot of condensation issues, especially with wood frames and so on. This is complicated, isn't it?
Yes. So it's it highly depends where you do your insulation. I mean, the example I showed, basically, the straw bale was really outside, like exactly like the polystyrene somehow, which means that it's not in contact with the indoor environment. We had the wall, like the existing wall, and then you put insulation outside. So this insulation will not increase, will not change your will not act on the indoor environment. And so if well, let's say this condensation question.
Let me focus a little. This was
Yes.
this is not an insulation issue. The insulation is all right, and it will not get wet or something. I was just talking about the window itself getting wet in winter, because it's so cold compared to a free pane window. So you have very warm walls, and then you have extremely cold window in comparison, you know, and you have a lot of water on the window. But this is just a side comment. Let's focus on.
Yeah, I mean, and that's when we come to kind of let's say in Switzerland, I think the windows, they are already relatively well insulated. So I mean, they have that's why I was saying that you should changing if you have not a good energy efficiency in the beginning, like this 150 kind of kilowatts per square meter, which usually in other country, non-insulated non-renovated building have higher energy performance than that. I mean, or higher energy consumption than that. So I'm not sure you condense, and the other point which I didn't put at all in the renovation, but it's this effectively this condensation issue. It's more how do you deal with your indoor environment, and how you can put some materials such as let's say wood and earth plaster, or even a hemp plaster inside your building, which actually will be able to regulate your moisture question. So you will absorb this extra moisture for your in your let's say relatively well sealed new renovated building. So it goes more from the inside on I don't think, yeah, if you change the triple glazing, it will still be the same question. Is more you would put an earth panel and keep the existing building, and then you will avoid your condensation question, I think. But maybe yes.
I hope, Michael, that's good for you. I propose we go on in the list. Maybe a question, Anke. I had to mute you before. Did you want to ask a question, or is that fine? I'm not sure if I muted you. There was just some background noise. If not, we just go to the next one. Saira has a very simple question. Can we get the presentation, please?
Yes, I don't know how to put it, but yes, of course.
Best thing, either you can put in the chat, otherwise, Saira, Guillaume Haber, ETH Zurich,
yes,
you find him online.
In the chat, effectively. Yeah, I do that. Then it's already done. Yeah,
if you can drop it, that would be amazing.
That's
perfect.
Yeah.
Let's go to the next one. Because we said that if you have a question, you should put on your video. VV, you put your video and then you close it again. I don't know if you have a question or if that's already answered. You put it on now, otherwise we go to the next one. And if I don't see you, which I don't, then we go to Jakob Schneider. Jakob, do you want to pose your question here? Jakob, otherwise I just read it.
Yeah,
Jakob.
Just read it. Hi everyone. Thank you very much again for this nice presentation. Yes, my question is how was it possible to have negative emissions achieved? Is this mainly because of a dynamic LCA, or how is it calculated? Because other
yes.
Yeah.
That's
okay.
that's a big well, I don't know how to put Microsoft SharePoint. I'm a bit I'm happy to share. I'm just struggling a little bit to find a way, but I just have access to OneDrive and not my. I will try. The question of the negative emission, it's a big discussion. There's different way. I mean, it's not necessarily dynamic LCA. It's just the question of, do you consider biogenic storage in the material or not? So in Switzerland, currently the standards do not have a biogenic material counted. In Germany, I mean, in the rest of Europe, you have a biogenic material counted. So if you're not in Switzerland, basically, when you put a biogenic material in the building, you consider that you have stored CO2 emissions. That's it. So it is negative. The difference, and then comes, of course, obviously the question of the end of life afterwards. Where you say, okay, I've stored in the beginning, but if I release afterwards, then it's not stored anymore. So what do you happen at the end of life? And what I strongly believe is that effectively I went a little bit fast, but it's like if let's put an example very simple. Like I renovate my building, I put 1 straw bale in my house. I have stored the equivalent of carbon of 1 straw bale. Effectively, when we will need to renovate the building again in whatever 30, 50, 60 years, there will be 1 straw bale. If someone is burning this straw bale, my storage is lost. But if this person is taking my straw bale that I put 50 years ago, burning it, whatever they want to do with it, and adding a new straw bale, then the carbon content in the building is kept the same. It is still 1 straw bale. It's not the same straw bale, but it's still the same carbon content. So the question of how do you count it, we can discuss if it's dynamic, not dynamic, things like this, but it is possible to permanently store carbon, even if I renew my materials inside. It is just a question of what people will do in the next 50 years, which you could say, okay, we don't know, so then let's not account. And my point is, like, if we have 10 years, I would go massively for straw bale now and think, what do we do with this straw bale in 50 years, rather than saying, let's not count the negative because people might remit afterwards. But that's that's a philosophical discussion. But so to answer your question, it's not necessarily dynamic, not dynamic. It is, do you take biogenic or not biogenic? And in Switzerland, we don't take biogenic, so you cannot be negative. In the rest of the world, I mean, the rest of Europe, you can be negative in the construction, and then you have the question of the end of life that you can handle by renewing your building. I mean, I on that, just to give an example, I'm sure you know, or at least you've heard about this. You have the buildings, I mean, extreme, but you have this Japanese temple that is, I mean, I don't know the name, but you know, is always new, because every 20 years they dismantle all the building and then they rebuild the building, and it's always done with new wood. And so the you know, the material, and yeah, has been there for like 5,000 years or so. The building is like you could say the carbon content, the equivalent of the building has been permanently stored for 5,000 years, but it is stored by always renewed materials that are always going out and in somehow. Which, I mean, for the Japanese temple is the question of preserving also the skills and how do you build. So it's another discussion, but I'm sure you can have to answer your question. I'm sure you can have a permanent storage of carbon, even though the material itself is not permanent, as long as you think about the maintenance and the renewal of these carbon stock. It was a long question, long answer to your question. Sorry.
Jakob, I hope that answers your question. Just with the time, and I think a couple of other questions I would go on. Yes, Jakob gives the thumbs up. Next one is rather a comment. Paloma El Hage, would you like to add on your comment that you made in a? It's a very extensive comment. I could read it, but maybe you would like to bring that in yourself, or is that for you?
Hello. Yes, I can hear me.
Yep.
Yes. It's just I'm not sure about the details of the study where they showed that with the scenario when we renovate, it was in the beginning to the maximum. Then we will have this in the end. We will have the same result as if we didn't do anything because of the embodied emissions. So I'm not very convinced of that. I'm not because it's not in line with many other studies which say that the embodied part is always so it will be paid back over the life cycle of the building, and because we save a lot on operational energy even without changing the heating system. So I had a quick look also at the study that I found of Priori. Sorry, I'm not sure about the pronunciation.
Yep.
But so they said that they took a share of embodied emissions for renovated buildings of 56%. So for me, it seems quite high. I mean, I have seen lower shares in other studies. So maybe because I didn't look into details, but maybe because this is applied. Of course, the embodied share is something we need to take into account and is very important. And we need to think about the material. But for me, it just seemed a bit, it's just strange as a result. So yeah, it's not a question, not a comment. I don't know.
Yeah, I mean, clearly, let's say, what I can say, let's say, is that the calculation that we did, we are confident in the result. Then of course it depends on the hypothesis you make and the current situation. So it is a very Swiss case where the operation emission, where, and that's where my point. I mean, where the energy consumption of the building is already relatively small, we have actually good building stock. So if you compare to Germany, France, this type, so we don't have like a completely uninsulated buildings. We have already good building.
Okay.
Then the second point is is not a question of energy, it's a question of carbon. So when we operate the building, if you use it with electricity, like heat pump, then the energy is really decarbonized. So even though you will consume energy, like your operation emission, your operation energy is not null, like you're not super energy efficient. Your energy, your carbon intensity of your energy is actually low. So you don't emit a lot during operation.
Correct.
That's the second point. And then your embodied emission, it is just fossil. It is just it is pure polystyrene windows, etc. So you're emitting a lot. So that's well, that's where we have here is like if this value, what we found, or you put it like this, this is the so 400, the maximum that we took, this where we say, okay, to reach this Swiss strategy, it is 400 CO2 per square meter that you need to divide in Switzerland by 60 years. So I'm super bad in calculation, but you are less than 10, 460, what it is, how much, you know? I'm
7.
It is how much? 420 divided by 60, 420, 10, no, 7, yes. Sorry. So yes, 7. So you have 7 kilograms CO2, which is what is the classic I mean, what is the sustainable strategy for like the 2000 watt society? That's where I think we are at 5. So the recommendation would be 5 kilograms CO2. So maybe it to be in accordance with your study is that the embodied emission that we show, it is you still have scenario where you are in the kind of sustainable path of Swiss strategy of renovation. So where you're like 5 kilograms CO2 per square meter per year, which is the 2000 watt society. So the type of labels that we show. So it means this scenario, it will still be possible. It is just that if you do that, then you need to be you have less options because you are already on the high range of the possibilities. I mean, I don't. Yes.
No, thank you. It's much clearer actually. Now. I understand also that the starting point is very important also to make sense.
Yeah, but it's not. It's. I think, or at least, because here we take you could say the other way of saying it is like the hypothesis that we take as business as usual. Maybe they are relatively high. The other way around is that we look at what are the way to achieve the 1.5, and then you say the way to achieve the 1.5, it is this. You need to renovate quite a lot between 3 and 10. So you need to, so the one doesn't work anymore. And then the operation emission, you can still have solutions where you're not completely zero compared to the if you think the again 2000 watt society, you have 2 kilogram maximum, 2 kilograms CO2 for a new, 5 for renovation. And you say, well, yes, but we could do more as long as we do super negative here, which the 2000 watt society, you would be at typically this 500 kilogram or 600 kilogram CO2. So and that's the point, is like we have solutions that are not helping that typically works if you allow a little bit higher emissions.
Thank you so much.
I don't think it's completely contradictory. I think it goes in the same line, basically. It is yeah. And then the other thing is that we are looking for the from now to 2050. So the question is also that that's the other point, is like if you look at the study, if you think your building will last until 2060, I mean 60 years, and that you look at the overall life cycle of your building, like yes, the operation counts more and more. But if we think the emergency is right now, then the amount that you emit the year 1 is what will control all your emissions, and not so much the operation afterwards. Yes. So of course, the longer the building lasts, the less your embodied is important. But the too late it is. I mean, if we think 2100, like yeah, who cares?
Yes. So yeah, I completely understood. Thank you so much.
But yeah.
Thank you so much, Paloma, for this very interesting question, and Guillaume for the answer. I'm looking a bit on the clock. I'd say let's extend a little bit, but not too much, over 9. I see the next question was from Christina, but it's, I think, already answered in the chat. Yes. Your comment on changing the heating system to renewable. Christina, do you want to follow up on this, or should we go to the next question?
Well, if somebody else has a question, it doesn't have to be always me. Otherwise, I'm happy to pose it. But if there are more questions,
okay, we jump to Shri Priya, and then we go to you, Christina. Shri Priya, am I saying this right?
Yeah. I have a question. Like you mentioned about using the renewable energy sources or heat pumps for as a heating source as a first strategy So in that, for example, in the UK, if we are living in an apartment, as a apartment owner, I cannot really opt for such kind of energy. So when I have to go as a whole, then the cost is more. So again, it becomes like not a straight solution for going for alternate source. So in that case, my cost is becoming high. So the initial barrier is there to adapt to that kind of energy, I mean, renewable energy. So the first strategy is, if it is compromised, then what is your take on going for a renovation? Like,
I didn't completely get the.
No, if the first strategy is you mentioned about using a heat source pump, right?
Yes, I mean the
air
yes,
source pump. But if I don't have that option, will your conclusion be still valid? And if it is if that strategy is needed, then what is your take on that? If
I think what we showed, I mean, what the PhD of Alina, what the work that she showed, and I think where we if most of the others agree, I think there's no disagreement, is that the change of your technical systems is the thing that has the highest influence. So if you stay with your oil or gas boiler, you can do all what you tried, all what you want. You will always you're struggling to reduce your emissions because exactly going back to this question of energy and carbon, you're still constrained by the fact that every energy that you consume is highly carbonized. So you have to reduce a lot your energy consumption by itself, and there. I mean, yes, and so that's the best investment, is to change the technical systems. That's the and then if you say you cannot because it is because you can renovate just one apartment, then I think you're in a different logic, in the sense that you will try to have to go in the renovation inside, like indoor renovation, where the indoor renovation, when you renovate when you put your insulation from the inside, you will never reach a super high energy performance, so you will not insulate very well. What you do is you just remove the feeling of cold wall, basically, in your building. So usually what you would do, and there again, bio-based material or like you have studied that renovation of historic building, where you say you need to renovate from the inside, you would do like 5 centimeter hempcrete or things like this, where it will insulate a little bit, so you avoid to have a cold wall, and then your bio-based material will avoid the problem of condensation of your wall, of your cold wall inside. So it will improve your feeling of warm, and therefore you will reduce your energy consumption because you will not feel that cold. And that's yeah. But it's I think it's effectively a different strategy than if you're able to put the full building and then you can insulate by the outside. Yes.
Sure.
In the meantime, Hans, I had we wanted to run I just put here the QR code, but we wanted to run a questionnaire. I didn't put it like this, but as we are kind of close to the end and maybe people will leave, we wanted to, I mean, that's the work that I put it like this, Alina, and now with people from Zeta Deca, Florina Gradin and Patrick Fararelli, we are running we would like to have your take on this, and so we would be really happy if you would fill this questionnaire that if you go to the QR code, you should access to it. and you don't need to. It can be anonymous, or you can fill your detail afterwards. You do what you want.
It's perfect. Stupid question. How do I go to a QR code to a video share, a screen share? Do you have like a web page, like a? With the
I
phone.
think if you, with
okay,
your iPhone.
Yeah, good. Got it.
Yes, you cannot click. Yeah.
Okay, got it.
But with your iPhone, it works. But if you already, yes.
No. Okay, so everybody, please take your iPhones, your smartphones, take that
it's in the
QR code
presentation.
and help Guillaume with his and his colleagues' work, please. I have two more comments, Guillaume, also to follow up. Everybody, Guillaume put the PDF of his presentation in the chat. Download it now.
And the link. Cool.
Yeah.
You put the Survey Monkey. Thank you. Thank you, Adriana. You can click on the chat also. No.
Saira, you wanted the PDF? It's in the chat. And
Thanks.
If I can also answer Salima, the recording of today's session will be published on the YouTube channel of Architects for Future. Just 2 administrative questions. Guillaume, do you have a couple of minutes more? We have
for sure.
Question from Christina. Christina, would you like to take it on?
Yeah, it's more like a comment on to follow up on the question of the heat pumps. And talking as an energy consultant at this time, not as an architect, I agree that we need to change the heating systems to renewable as a first and most important thing. But practically talking, I cannot install a heat pump in a building talking energy class F or worse, where I need a very high temperature to heat up that building. So for me, the first step in my consultancies that I do is always to reduce the heat demand in order to be able to install an equipment that after is also from the power working for the renovated building. If I install it first, I would have a heat pump that is
not
needed
efficient.
10 times higher than it would actually be after renovation of the walls or of the roof. So there's a little bit of a conflict that I don't know how to deal with.
No, and exactly. I think you're totally right. And that's the point. Is like if you put or put it like this, effectively, if you don't put insulation, your heat pump is not working efficiently, so you consume a lot of electricity. You're not working at the optimal way of doing your heat pump. If the electricity is decarbonized, it will still be better from the CO2 perspective to run an inefficient heat pump than to put polystyrene outside. Because the polystyrene is pure CO2 and your electricity is not CO2.
Good, but you're talking with Architects for Future. You know, we're not using that material.
Yeah, exactly. But that's the point. Is like if you want to, if you say I first insulate, so I first replace my window and put polystyrene in order to have an optimal run of my heat pump, you think from an energy perspective, but the carbon is actually not. It will have too much carbon, or at least it's you could have had lower carbon by just putting your heat pump and lower investment. But there I totally agree with you. It doesn't make sense for the user to put a heat pump and to pay and to have it run as a super bad efficiency coefficient because you're not insulating, and you say it's better for the climate. It's like maybe it's good for the climate, but I still need to pay the energy by Swiss franc, and so it doesn't make sense. And that's where we are reaching the idea of saying that's why you need to think about the type of material that you put in your insulation, and that if you put, I put the example of straw bale, but you have other environmentally friendly materials like your wood wool, cellulose, and plenty of others that are much more conventional than straw bale. But if you put a low carbon intensive insulation material, then you don't increase too much the emissions for the insulation. And then effectively, I totally agree with you. you have a better energy envelope, and so your heat pump is much better used, and so you consume less energy, and so you pay less, and you have also running the heat pump at the right temperature is also better for the maintenance, etc., etc. But our point was that the type of material you put into your insulation, it's critical if you want to if you want to reduce your energy consumption. And if you just want to reduce the carbon and that you don't have a lot of money, you better just change the heat pump rather than putting polystyrene and thinking you're doing good. That was the point, but maybe it's a bit extreme. But yes, I think I agree with you. It doesn't make sense to put just a heat pump, but then it means what makes sense is to put the heat pump with low carbon insulation materials. And then effectively, as an architect for the future, of course, you will use cellulose, at least minimum. Then it's fine.
Thank you so much, Christina, for this good question, and Guillaume for the answer. As a comment, Guillaume, Christina is from Architects for Future in Germany, Munich, I think, Christina. And she did great work about, and Christina, you correct me, about Hindernisse beim Bauen im Bestand. So maybe you guys would like to follow up. I think you have shared interests, shared fields of that you work in. So I think Christina, you're even coming to Zurich soon. So maybe you guys
yes,
have can take this conversation further.
Great.
I'm just looking at the list. I see there's a comment from Michael still. Michael, would you like to extend on this, or is it fine in the chat?
I think it's fine. Thank you.
Okay, thank you, Michael. Then Charlotte, I saw, Charlotte, you put your video on. You have a comment on straw bale, or is it fine for you also, Charlotte? If you're still here?
Yes. No, it's fine. But I think I just wanted to point out that for us today, of course, it's also important to keep the carbon stock that's already there. If we have a bit, but there was wood or building, then we have to add a minimum of this and better, and only the plus we can add for our carbon storage, because on already there we shouldn't lower the carbon storage. And I mean, it's discussion going on how to count carbon, and for me that actually, as Guillaume also explained, sufficient way to just you are only allowed to add the delta, and that means that we are getting into the discussion of how we have punished for taking buildings down, and that's a whole other question. But
no, I mean, I totally agree with you, Charlotte. It's like, if you cut a forest to build a building and then you say, oh yes, but it's a building in straw bale, it's like, yeah, but you have cut a forest before, so you need to count what is on the spot. And so forest is the easy example, but then it's the same as you have no,
and forest is the worst example, right? But it's a super important one. And if you take down an old Wallis
and then
wood house, it would be the same, right?
Exactly. And that is the same if you have your existing building, you have a stock of carbon, and then you should think about the what is there, and that you have increased effectively. And then you just think about increase. So how much is there, and what my new building is providing, and to be sure that it's providing more. And then you just effectively count the difference. And I think it goes back to this initial discussion about dynamic LCA, and it's like in general, you need to increase the stock of carbon in your building stock. And then it's fine. So effectively you think what you have on the spot, and you make sure that your action somehow is contributing to an addition. And it's the same for the because you're I think it's exactly the same for the reuse question, but that's another discussion. But you know, you have an existing building. If you demolish this building before it's completely lifetime accounted, you should take the remaining embodied emission somehow.
Yeah.
And then you carry this. And so if you have a good justification of demolishing, why not? But at least you need to consider this existing remaining embodied, like the rucksack somehow of this.
No,
and so
I
think
try
it's
to argue with.
But it goes in the same logic of the biogenic and the reuse is like you need to put the existing and to do better afterwards.
Yeah.
Which is absolutely not in the labels, because the label, they start at the construction of the building.
Yeah.
Thank you so much, Charlotte and Guillaume. I see there's one last comment and one last question. Is it still fine for you, Guillaume? We take those two?
Yeah.
Niels, I don't know, it's a comment more, or would you like to elaborate on it? About heat pumps, Niels?
No, that was just a comment about the apartment where you can't change the heating source. That those air conditioners may be an option to reduce your carbon emissions for your heating, to use less of your fossil fuel heating just in your apartment. That was just a hint that there's an option.
To this.
Very good. Thanks, Niels. And then, you know what? I have now one last question from Jakob Schneider in the chat. By the way, Guillaume, a couple of people already had to leave, but I have many thanks in this chat. I think you were very well received.
How much budget is left?
I like Jakob Schneider's comment. How much?
It's a difficult, because if it's the last discussion, it could open to a like a 2 hours beer drink on what is the best way of splitting the remaining budget. To make it, because
make it 2 minutes without beer.
Make it 2 minutes. So what we showed is this in this diagram of Yasmin is the official 2050 strategy of Switzerland. So which accounts a certain budget that you basically you split per capita, the existing people more or less. And so here it looks like you still have budget. If first, let's say from a fairness perspective, if you are really serious with the climate, so serious with the global south, you would say, serious with the responsibility of the European activities over the last century before starting to consider the climate, and serious about the fact that it's not 1.78 degree, it's actually 1.5. This is and not with 50% chance, with 70 at least % chance of achieving the 1.5, then you have no budget. Then even more is like we should even pump, and that's a bit what we showed. It's like the embodied emission, it should be negative. Like if we should repair. I mean, and that's the other way around. Is like we already have climate change. So in real, we should try to repair what we have already done. So, but if you start to say we have no budget, then it's not an operating mode for society. So you still need to give a budget, and at least the Swiss, what you showed, I mean, what we showed with this 1.52 degree, like the Swiss strategy is somewhere in between, which is already not too bad compared to some other place in the world. So it's not enough, but it's already something. But yeah, that was the 2 minutes trying to wrap up the philosophical things. But Jakob would be happy to have a beer at one point to discuss longer.
Well, I think let's take this as an end to this discussion. I see many thumbs up and hearts and clapping emojis. So I assume that was a good question. No, excuse me, a good answer to that last question. I'm looking at the clock, and we have much too much time spent. It was amazing, Guillaume. I really loved it. But I would propose maybe let's close just this formal part of the evening. And Guillaume, we're not letting you go though, or already yet. Let's close the formal part, and then we can still everybody.
Thank you for your question. It was really, yes, it's much more interesting to discuss than just.
Yeah, no, it was awesome. I think it was really.
Thanks a lot.
Wertvoll. But Guillaume, before we say thanks to you, I will take advantage of the situation that we're still here. Everybody just stay longer if you want. We can continue discussing just without me moderating. But today, Guillaume, a really heartfelt thank you from everybody here, from everybody at Architects for Future. It was really inspiring. I would like to remind everybody, Guillaume asked for your help with his QR code, but if you go in the chat, there is also the link. Adriana Lemus posted the link of Guillaume's survey. So everybody, please help Guillaume with his questions and fill out that survey. I think that would help him out a lot. Please, everybody, see who was here today. Maybe link up on LinkedIn afterwards, or write someone an email if you like their comment. Write Guillaume an email if you have further questions, or if you disagree completely. Let's take this discussion further.
Yes.
And I hope that's okay, Guillaume.
No, for sure.
We didn't discuss this.
As long as it's a friendly discussion, it's fine.
No. And the only thing left for me is to make one comment. On Tuesday, the 13th of June, we will have another webinar here at Architects for Future, that time with Robert Gentner about Stampflehmturm-Cham von Tradition zur Innovation. So rammed earth tower Cham from tradition to innovation, another project about, let's say, sustainable construction.
A beautiful, piece.
I hope we see you. Come watch it, Guillaume. So I expect you in the audience on June 13. But with this said, another thank you to you, Guillaume, and a big thank you to everybody who came here tonight to listen, to participate in the conversation. It was really awesome. And now if you want to just let's chat informally, but the formal official part of this evening is now over. Thank you so much.